This is where you're going to find the periodic table. And the elements you need to identify pretty quickly are the most common elements. So you should know hydrogen is H. You should know lithium is Li. You should know sodium is Na. You should know potassium is K. You should know that this is calcium, magnesium, beryllium, and if I move over to here, boron, carbon, nitrogen, oxygen, fluorine, aluminum. These are some of the common elements that you should know what their initials are in the periodic table. So when I look at hydrogen here, there's a top number and a bottom number. The top number represents the atomic number. The bottom number is known as the atomic weight or the atomic mass of that element. So how do we identify the number of protons, neutrons, and electrons in elements? Well, when you're looking at those numbers, the top number, which is the atomic number, is usually represented as the variable Z, and it's equal to the number of protons in the nucleus. Now, why is it also equal to the number of electrons in the nucleus? And that's a question to you guys. Why does that atomic number also represent the number of electrons? Yeah, so all of these elements are neutral and they do not have a charge associated with them. These elements, these atoms of elements, are stable. So if you know that the number of protons in the nucleus, so in the case of carbon, you have 6 protons, you know that if it's not a charged carbon with a -1 or +1 charge, you know that there are also 6 electrons in that nucleus. So the top number in that box tells you what the number of protons are and what the number of electrons are. Now, what's the bottom number? The bottom number can be referred to as the mass number A. It's also called the atomic weight or the atomic mass. So that A represents the number of protons plus the number of neutrons. Now, why aren't the number of electrons included in this formula? Yeah, so if you remember, the mass of electrons relative to protons and neutrons is significantly smaller. So it won't have a major bearing on the total mass number. So this value here, this 12, approximately 12.011, is equal to the number of protons plus the number of neutrons. So if I know I have 6 protons and my mass number is 12, approximately 12, how many neutrons are in a standard carbon atom? Yeah, so 6, right? So these are just basics you need to know before we get into the more complex stuff. So this is how it's represented in your periodic table. But on the exam, they sometimes like to use this format for representing elements in problem statements, where A is up top and Z is on the bottom next to the element. So A is your superscript, Z is your subscript. So just be aware of that. If they present this to you, then what they're saying is 6 is the atomic number and 12 is the atomic mass.